Usually when you look at the theoretical architecture of a website, there's this expectation of like strict hierarchical order.
Right, like a perfectly organized filing cabinet.
Exactly. You build a taxonomy, you assign your categories, and every single piece of content maps cleanly to a destination.
In theory.
Yeah, in theory. But anyone who has actually spent time in the back end of a decade-old enterprise CMS, whether that's some heavily customized Drupal instance or a massive multi-site WordPress network, they know that theory just rarely survives reality.
Oh, it never survives. You give it 10 years, and suddenly you have dozens of marketing teams running separate campaigns.
Yep. And regional managers spinning up localized subdomains, right? Plus those automated scripts generating just thousands of programmatic landing pages.
And before you know it, you're not managing a digital library anymore. You are managing a data landfill.
A data landfill. That's a perfect way to describe it.
Yeah.
Because you get this sheer accumulation of legacy articles, expired event promotions, discontinued product pages. It just creates a state of severe digital bloat.
We're talking hundreds of thousands, sometimes millions of thin, zero-value URLs.
So that is our mission for today's deep dive. We want to provide enterprise developers, site managers, and technical SEOs with a confident, technically sound roadmap for content pruning.
And we aren't just guessing here. We are pulling this framework directly from a really authoritative stack of sources.
Right. We've got the official Google Search Central documentation, specifically looking at their guidelines on crawling infrastructure, HTTP status codes, redirects, and content removals.
We're also digging into a really comprehensive enterprise case study guide on content pruning that was published by Ahrefs.
And maybe this part. We have direct technical clarifications from Google's John Mueller. He specifically addresses how indexing systems actually process deleted content, which is a huge sticking point for a lot of developers.
It's a massive source of panic, yeah.
So to start off, leaving these massive amounts of outdated, low-value content on an enterprise domain, it's not just a database storage issue, right?
No, not at all. It actively drags down your entire search presence.
Because of the crawl budget problem.
Exactly. I mean, for a localized 50-page business site, crawl budget is basically a myth. It's irrelevant.
Because the crawler just hits the homepage, follows the navigation, and processes the whole thing in, like, milliseconds.
Right. But at the enterprise scale, when you're covering millions of URLs, Googlebot is operating under strict resource constraints.
Like, they don't have infinite processing power to just crawl your junk forever.
Exactly. Google allocates a finite amount of computing power to crawl a specific domain. And that's based on server capacity, but also on the perceived value of the site.
So how does that actually play out in real time?
Well, the mechanics of that allocation dictate that Googlebot operates on a schedule. It basically has a crawl queue.
Okay, a queue.
Yeah. So if an enterprise site is forcing Googlebot to spend, say, 80% of its allotted crawl capacity parsing expired 2018 webinar registrations.
Oh, man. Or those auto-generated author tag pages.
Yes. If it's chewing through all that, the crawler might literally never reach the actual high-converting core product pages that are buried slightly deeper in the architecture.
So you are actively hiding your own most critical revenue-driving assets.
Right. You're choking the crawler's queue with digital deadweight.
You know, a good way to think about this, imagine Googlebot is a health inspector.
Okay, like this.
And this health inspector only has exactly 1 hour to inspect a massive luxury hotel.
Right.
If you make them spend 45 minutes opening abandoned storage closets, which would be your old event pages, they might never even see your luxury suites, your core product pages.
That's a great analogy. And beyond just the sheer logistics of the crawl queue, the sources also really highlight the impact of Google's helpful content system.
Right, because that system looks at the site as a whole, doesn't it?
Exactly. It evaluates content quality not just on a page-by-page basis. It's a site-wide signal.
So if you have a ton of garbage pages, it drags everything else down.
The official documentation clarifies this. Hosting a high volume of unhelpful content creates this overarching negative halo effect. The algorithm is assessing the aggregate utility of your domain.
So if 90% of your site's URLs are thin, outdated, or just useless, that negative quality evaluation actually suppresses the search performance of the 10% of pages that are genuinely authoritative.
Which is wild when you think about it. You could have world-class content, but it won't rank because it's sitting in a landfill.
So trimming the unhelpful content isn't just about saving crawl budget. It's a direct mechanism for allowing your valuable pages to rank at their true potential.
Yeah, and the RF's data gives us a really striking look at the math behind this.
Oh, the Francesco Baldini audit, right?
Yes, the vehicle valuation platform. This site was just hemorrhaging its crawl budget on millions of low-quality programmatic pages.
These were those auto-generated permutation pages, right? Like combinations of vehicle makes, models, years, and locations.
Exactly. Pages like 2008 Honda Civic in specific small town. They offered zero unique value and, unsurprisingly, received zero organic traffic.
So what did they actually do?
The pruning operation they executed was staggering. They deleted almost 5 million URLs.
5 million. That's insane.
They reduced the site's total footprint from over 4.8 million pages down to just 1,500 core pages.
Okay, trimming 99% of a site footprint, that is a terrifying proposal to bring to most C-suites.
Oh, I'm sure that was a fun meeting. But the analytics completely validated the risk. Following that massive reduction, organic visits to the platform increased by 160%.
Wait, really? 160% increase in traffic after deleting 99% of the site.
Yep. And overall conversions rose by 105% within weeks.
Because they just stripped away all the noise, they forced the search engine to allocate 100% of its crawl demand and indexing power to those 1,500 URLs that actually served a real user intent.
Exactly. And we see a very similar acceleration in another case study mentioned in the sources from Victor Pan at HubSpot.
Oh yeah, what did HubSpot do?
His team removed about 3,000 outdated URLs from their architecture and their XML sitemaps.
Okay, so a smaller scale, but still a solid cleanup.
Right. And the immediate operational benefit they experienced was this hyper-acceleration in their indexing speed.
How much of an acceleration?
Prior to the prune, getting a newly published article crawled and indexed took days. After eliminating just those 3,000 deadweight URLs, their new content was being crawled and indexed in a matter of minutes.
Wow. So when you optimize the crawl queue, you're literally optimizing your entire publishing pipeline.
Exactly. It's night and day.
So the data clearly points to ruthless deletion as the optimal strategy for this kind of enterprise bloat. But having worked with technical teams, they consistently hesitate to actually hit that delete button.
Oh, they're terrified of it.
Because there's this deeply ingrained practitioner panic regarding 404 errors.
The dreaded 404 penalty myth.
Right. There is this persistent myth that returning a 404 not found status code acts as like a demerit against the domain, triggering some sort of algorithmic penalty.
Yeah, developers see their Google Search Console coverage reports flashing red with all these 404 warnings, and they instantly assume the site's health is just failing.
But our source material directly dismantles that myth completely. We have that definitive statement from John Mueller addressing this exact panic.
It's one of my favorite quotes from him.
What does he say again?
He says, and I quote, "Every now and then I run into folks asking whether 404s are bad for their site and whether they need to fix these errors somehow for SEO. The answer is a clear no. 404s are fine."
404s are fine. I mean, it doesn't get clearer than that. He confirms that returning a 404 or a 410 status code is the technically accurate expected method for handling URLs that no longer exist.
Right. A 404 is not a quality signal. It's not an SEO signal. It's just a factual server response.
I think the critical distinction we have to make here for people listening is the difference between an accidental 404 and an intentional 404.
Yes, that is vital.
Because Google Search Console is not handing out a grade, right? It's just providing a server log aggregate.
Exactly. It's just telling you what happened.
So if a developer intentionally deletes 5,000 legacy articles and then Search Console subsequently reports 5,000 new 404 errors, that dashboard is simply confirming that your implementation was successful.
Right. The crawler requested the deleted URLs, the server correctly responded that they were gone, and Search Console logged the transaction. Everything is working perfectly.
The only time a 404 is an actual emergency is when it occurs accidentally on a revenue-generating page. Like if your checkout flow breaks or a high-traffic landing page goes down.
Yeah, if your money page 404s, panic. But an old 2015 press release, who cares?
And the crawling infrastructure documentation explains exactly how these status codes are processed in the pipeline, right?
It does. When Googlebot encounters a 4x client error, specifically a 404 not found or a 410 gone, it processes that as a directive.
It's just a simple command.
Right. It drops the URL from the index entirely. And then over time, the system algorithmically decreases the crawling frequency for that specific URL.
So it stops wasting time on it.
Exactly. And crucially, processing a 404 does not penalize your crawl rate limit. It doesn't hurt you.
Is there any 400-level error that actually does signal a problem to Googlebot?
Yes, the only one that signals a negative server health issue is a 429.
The too many requests error.
Right. A 429 tells the crawler to back off because the server is getting overloaded. But standard 404s, completely harmless.
Now, contrast that harmless 404 with the immense damage caused by serving a 200 success status on an empty page.
Oh, this is where things get really messy.
Right. So imagine a CMS is configured to delete the content of an event page, but it leaves the site navigation, it leaves the footer, and maybe a blank content body that just says, event over.
Right, the template is still there.
Exactly.
Yeah.
And the server still returns a 200 HTTP status code.
Yeah.
You are feeding the crawler completely contradictory signals at that point.
You're telling the server, hey, this page is a valid, successful destination, which forces Google's rendering service to process the DOM.
And that is where the crawl budget is actively wasted, right?
Completely wasted. Googlebot downloads the HTML, it executes any JavaScript, it parses the layout, only to discover that the main content block is entirely empty.
And what does the rendering engine classify that as?
It flags it as a soft 404. It's a page that is practically devoid of unique content, despite having that 200 success code.
But by the time the system actually flags it as a soft 404, the processing power has already been burned.
Exactly. The damage is done. Serving a hard 404 or 410 right at the server level prevents the crawler from ever needing to render that empty DOM.
Okay, so developers have historically feared that 404 report in Search Console. So instead of deleting, they often pivot to this different, deeply flawed strategy, which is mass noindexing.
Oh, the mass noindex band-aid. We see this all the time.
So instead of deleting the content and returning a 404, they just keep the pages live and they inject a noindex tag.
Usually via a meta tag in the HTML head or maybe an xrobots tag in the HTTP header.
Right, and their assumption is, oh, this preserves the site's architecture while telling Google to just ignore all this bloat.
But that is a fundamental misunderstanding of crawler behavior and resource allocation.
Because Google still has to crawl it, right?
Yes, the Google documentation states this explicitly. It says, we have to crawl your page in order to see meta tags and HTTP headers.
So if an enterprise team applies a noindex directive to, let's say, 50,000 low-value URLs,
Googlebot still has to allocate bandwidth to visit every single one of those 50,000 URLs. It has to initiate the HTTP request, download the payload, and parse the header information just to read that noindex command.
So you haven't conserved the crawl budget at all.
Not even a little bit.
You've merely shifted the waste from the index pipeline over to the extraction pipeline. It's like putting a do not enter sign on a door at the very end of a long hallway.
I love this.
The security guard, who is Googlebot, still has to walk all the way down the hall just to read the sign. You haven't saved them the walk. You've just wasted their time.
That is exactly what happens. And the timeline for this band-aid is brutal too.
How long are we talking?
Well, the documentation notes that for low-value, deeply buried legacy pages, it can take Googlebot months to prioritize a recrawl.
Wow.
So the site just continues to bleed crawl capacity for months while waiting for the crawler to discover these new noindex tags.
And the situation actually deteriorates even further when developers try to get clever and force the issue by combining directives.
Oh, yes. The paradox.
Right. A really common enterprise mistake is applying a noindex tag to a directory of legacy content and then simultaneously adding a disallow rule for that same directory in the robots.txt file.
They assume they're building like a double layer of defense, a belt and suspenders approach.
But they are actually creating a massive technical paradox.
Yep, because the robots.txt file is the very first thing Googlebot checks before crawling a domain.
Right.
So if the disallow rule forbids the crawler from accessing a specific URL path, Googlebot obeys. It drops the request.
And because the request is dropped, the crawler never downloads the HTML head or the HTTP headers.
Exactly, which means it never sees the noindex tag.
It's totally blind to it. And the consequence of that paradox is pretty severe.
It's awful. If external sites on the internet are linking to that legacy URL, Google systems are aware the URL exists.
Right.
But because they're blocked by robots.txt from seeing the noindex tag, Google might still index the URL based purely on those external link signals.
So the page actually appears in the search results.
Yes. It shows up as this bare URL, often with a snippet saying something like, no information is available for this page.
Because the crawler knows it exists but isn't allowed to read it to know it shouldn't be there.
Exactly. So by trying to combine a noindex with a robots.txt block, Developers effectively trap their digital garbage in the search index indefinitely.
Which is the exact opposite of what they wanted to achieve. So knowing that simply ignoring the pages destroys your site-wide quality signals and mass noindexing is an inefficient band-aid, we really need a surgical approach here.
A very precise, data-driven pruning matrix.
Right, because you cannot make these decisions based on a URL's age alone. Like, just because a page is from 2018 doesn't mean it's trash.
Exactly. An enterprise team has to merge massive data sets to execute this properly.
So what are we looking at? Traffic.
Traffic is step one. They have to pull organic traffic metrics from the Google Search Console API. Then cross-reference that with backlink data from a tool like Ahrefs.
Okay, traffic and links.
And ideally, overlay server log files too, so you can see exactly how often Googlebot is actually hitting these URLs.
Now, a quick technical note for the listeners. The limitation of the standard Search Console UI is that it caps exports at 1,000 rows.
Which is completely useless for a site with 1 million pages.
Right. So enterprise teams really have to use Python scripts, leveraging the Google API client, or maybe a connector in Looker Studio, to extract the full spectrum of that URL data.
You need the whole picture. And once they have that merged data set showing traffic, links, and bot hits, they can start filtering the URLs into 4 distinct strategic pathways.
Okay, let's walk through this 4-step decision matrix. The first pathway is what we'll call the salvage operation.
The salvage operation, okay.
This applies to URLs that still generate organic traffic or rank for relevant keywords, but the content itself is objectively low quality, outdated, or just unhelpful.
Ah, right. The Ahrefs case study featuring Eugene Zatichuk at Belkins provides a perfect model for this.
Yeah, tell us about that one.
They identified these URLs, like there was this AI-generated article targeting the phrase sales lead job description.
Classic AI content play.
Right. And it was pulling in traffic based purely on keyword density, but it was failing entirely to satisfy the user intent.
Because the article didn't actually contain any job descriptions.
Exactly. It just ranked because of the keywords.
So in a salvage operation, you preserve the URL structure, right?
Yes, you keep the URL. The page has already established a foothold in the search index. It's proved it can attract clicks. Deleting it would be throwing away an active asset.
So the required action here is a complete rewrite.
You get the unhelpful content and rebuild a high-quality, comprehensive resource on that exact URL.
Transforming a liability into a genuine asset that actually satisfies those helpful content criteria.
Precisely.
Okay, so that's pathway 1. High traffic, low quality, so we rewrite. The second pathway is the link equity preservation.
Right.
This scenario covers URLs that generate absolutely zero organic traffic and have no utility for users today. Think of a discontinued products from 2016, or maybe an old press release, but they possess a really strong backlink profile.
Maybe some authoritative industry blogs or news outlets linked to that URL years ago.
Exactly. So if you execute a hard 404 on that URL, you permanently sever those inbound links. You are just discarding valuable domain authority.
Which you never want to do.
Yeah.
So the technical protocol here is a 301 permanent redirect.
Right.
You must redirect that legacy URL to the closest matching, currently relevant page on your domain.
And this requires some real precision in canonicalization, because Google's algorithms use HTTP 301 and 308 status codes as strong signals to transfer canonical status and link equity from the old URL to the new target.
Yeah, the implementation mechanics here are absolutely critical.
How so?
Well, enterprise environments cannot rely on basic CMS plugins that write redirects into the database layer.
Like those standard WordPress redirect plugins.
Exactly, because that forces the server to load the entire application framework just to process a single redirect. It's terribly inefficient at scale.
So where should they be executed?
At the server configuration level. If the infrastructure runs on Apache, the team needs to utilize Modalias or mod rewrite directives in the .htaccess file.
Okay, and for NGINX?
For NGINX environments, they need to write specific rewrite rules directly in the server block configurations.
And the architecture of those server rules really matters immensely, because a major trap enterprise teams fall into is generating these massive one-to-one redirect mapping files.
Oh yeah, files containing literally tens of thousands of individual lines of code.
And that can severely bloat the server's memory, right? It increases the time to first byte or TTFD as the server has to scan this massive file for every single HTTP request.
It's a huge performance drain. Wherever possible, technical SEOs really must use regular expressions, or regex.
Right, to redirect entire folders or URL patterns dynamically with just a single line of code.
It vastly improves server efficiency.
One other thing on redirects, the Google documentation explicitly warns against using JavaScript for these redirects.
Oh, absolutely. Do not use JS for this.
Right. If a developer uses like window.location in a script tag to bounce the user, they are relying on Google's web rendering service to execute the redirect.
And rendering requires significantly more computing resources than just parsing HTML.
Plus, it's prone to failure, right? Due to timeouts or blocked script resources.
Exactly. If the rendering fails, the crawler never executes the JavaScript, it never sees the redirect, and all that link equity is just lost. Server-side HTTP headers are the only acceptable method here.
Good to know. Okay, let's move to the third pathway in our matrix, the consolidation.
Right, consolidation.
This addresses the problem of keyword cannibalization and structural bloat. This is where a domain has spawned multiple overlapping, really thin pages that all touch on slightly different facets of the exact same topic.
Which happens constantly over a decade of content creation.
Right, and none of these pages are authoritative enough to rank well individually. They just dilute the site's topical relevance.
So the strategy here is to extract the valuable information from all those scattered thin pages, merge it into one definitive master page, and then implement 301 redirects from the old URLs to the new consolidated asset.
And the RF's guide actually highlights an incredible case study from Brian Casey at IBM that demonstrates the UX impact of this approach.
Yeah, what did IBM do?
His team targeted over 1,000 pages specifically within IBM's main site navigation. They analyzed their product architecture and found redundant page types for single products.
Like what?
Like they had separate URLs for features, separate URLs for FAQs, separate URLs for pricing.
Oh, wow. So a user has to click around constantly just to understand one product.
Exactly. So by aggressively consolidating these overlapping pages, they physically flattened the site's architecture.
Right, bringing everything closer to the surface.
In one instance, a user journey that required 5 clicks through 5 distinct pages just to locate a robotic process automation product was reduced to just 2 clicks.
That is a massive improvement in user experience.
And the downstream effect of that consolidation is what makes it so powerful. To measure the success of a flattened architecture, we look at the Net Promoter Score, or NPS.
Which gauges a user's overall satisfaction and likelihood to recommend a platform, right?
Exactly. By drastically reducing the crawl depth and removing the friction of clicking through all those thin pages, IBM's NPS for their site navigation improved by 30%.
30%. That's huge for enterprise.
Shrinking the digital footprint directly enhanced the perceived value and usability of the entire domain.
That's a great win.
Okay, finally, we arrive at the fourth pathway, the hard delete.
The true prune.
Exactly. This is the final destination for URLs that have 0 organic traffic, 0 valuable backlinks, and 0 overlapping content worth consolidating.
These are the millions of programmatic pages from that vehicle platform case study, or the thousands of expired webinar promos, just pure junk.
The protocol is to just delete the content and return a 404 not found or a 410 gone status code.
Now, you mentioned 410 earlier. A 410 is technically a more explicit signal, right?
Yeah, it tells the crawler the content was intentionally removed and will never return, which can marginally speed up its removal from the index compared to a standard 404.
But functionally, both achieve the same goal of dropping the dead weight.
Right. But wait, before we ruthlessly hit delete on these scenario 4 pages, how do we factor in pages that have 0 search traffic but might have a non-traffic benefit?
What do you mean?
Like a sales enablement PDF or some historical press release. Is this purely an SEO decision?
This is where a hard delete at the enterprise level cannot be a unilateral SEO decision. This is where cross-team auditing becomes mandatory.
Because other teams might need those pages.
Exactly. A URL might show 0 traffic and 0 links in an SEO dataset, but it could be a highly specialized sales enablement PDF that account executives email directly to enterprise prospects every single day.
Oh, right. Or it could be a regulatory compliance document from 2015 that the legal department is legally required to host on a public URL for audit purposes.
Yes. If the legal or sales teams veto the deletion of a page that offers 0 value to search engines, that is the single isolated edge case where a Noindex tag is actually appropriate.
Really? So you keep the page live for the specific internal stakeholders, but you accept the minor crawl budget hit to keep it out of the search index.
Exactly. It's a compromise.
Yeah.
But for the vast majority of legacy marketing bloat, the hard delete is the answer.
Okay, so establishing this matrix, rewrite, redirect, consolidate, delete is a great theory, but executing this logic across hundreds of thousands of Drupal nodes or WordPress custom post types, that requires requires meticulous risk containment.
Oh, absolutely. The blast radius of a botched enterprise pruning operation is massive.
Yeah, if an engineering team simply runs a database script to drop 50,000 URLs without handling the collateral damage, the site architecture will just collapse.
The most immediate collateral damage is always internal linking.
Right, because a URL doesn't exist in a vacuum.
No. If you execute a hard delete on 5,000 legacy articles, but your site's navigation, related posts, widgets, and in-content body links are still pointing to those deleted URLs, you have instantly generated 5,000 broken internal links.
Which creates massive crawler traps. Googlebot wastes time following internal links only to hit 404 dead ends, and it ruins the user experience.
So before a single page is deleted, the technical team must run a full site crawl using an enterprise crawler like Screaming Frog or Sitebulb.
Ideally on a staging environment, right?
Always on staging. They must extract every single internal href tag pointing to the target URLs. Then, when the URLs are deleted, the development team has to run queries against the CMS database to systematically remove or update those internal links so the architecture remains clean.
And the same strict protocol applies to XML sitemaps.
Right. Yes, 100%.
Because an XML sitemap is essentially a direct roadmap, you hand to Googlebot dictating exactly what you want crawled. If you delete 50,000 pages, but leave their URLs in the sitemap, you are actively instructing the crawler to go inspect 50,000 dead ends.
It's so counterproductive. The sitemaps must be regenerated dynamically the moment the URLs are removed, and the search engines should be pinged with the updated sitemap paths to accelerate the reevaluation of the domain.
Furthermore, when executing the link equity preservation pathway, those 301 redirects teams really must be hyper-vigilant about redirect chains and relevance.
Oh, redirect chains are a nightmare.
That's when URL A redirects to URL B, which later redirects to URL C.
Right, and every single hop in a chain dilutes link equity and increases latency. The architecture must be audited to ensure all legacy URLs redirect directly to their final 200 OK destination in a single hop.
And the relevance of that final destination is completely non-negotiable. Because a classic lazy enterprise maneuver is discovering a legacy page has a backlink, but they lack a relevant consolidated page. So the team simply 301 redirects the old page to the corporate homepage.
They assume the link equity will just wash over the domain.
But the Google documentation explicitly warns against this practice.
Because if the system detects that a specific topical URL is redirected to an irrelevant page like the homepage, it classifies that redirect as a soft 404.
Wait, a redirect can trigger a soft 404?
Yes, Google recognizes that the content of the target page is not a close match to the source page, so it refuses to pass the canonical status or the link equity.
Wow. So if you cannot map a legacy URL to a highly relevant close matching category or product page, you're better off just executing a hard delete.
Exactly. A forced irrelevant redirect is literally worse than a 404.
Okay, so the technical execution has to be flawless, but the pacing of this execution is just as critical.
The pacing is everything.
The AIRF's playbook strongly advocates for deleting in isolated batches. Now, I know an engineering team might just want to rip the Band-Aid off and deploy the massive deletion script on a Friday afternoon.
Never do it on a Friday afternoon.
Right. But why not just get it over with all at once?
Because introducing that many variables at once is a recipe for a disaster.
Right.
If organic traffic plummets by 30% the following Monday, diagnosing the root cause is impossible.
Right. Did the drop occur because of the deleted event pages? Or maybe a misconfigured regex redirect rule that accidentally caught active product pages? Or a massive spike in broken internal links?
You'd have no idea. That's why batching isolates those variables.
The Belkin's case study is a great masterclass in this approach, actually.
What was their pacing?
Their engineering team targeted one specific subfolder of legacy content per week. They would execute the matrix on that single folder, monitor the Google Search Console index coverage reports and organic traffic logs for 7 days, and then measure the impact.
That's smart.
If the site metrics remained stable or improved, they proceeded to the next subfolder. If an anomaly occurred, the rollback procedure was limited to just a single week's worth of isolated changes.
It contains the blast radius.
Exactly. Now, the final and perhaps most difficult layer of risk containment is stakeholder management.
Oh, absolutely. The technical logic of crawl budgets and canonicalization means nothing if the chief marketing officer refuses to let you delete their pet project from 5 years ago.
So true. And Brian Casey's approach at IBM is a fantastic blueprint for enterprise SEOs here. He dedicated weeks to intensive cross-functional meetings before touching a single line of server code.
Weeks of meetings just to delete pages.
Yes. And his psychological framework for those meetings was highly strategic. He entered the negotiations with a mental model aiming to achieve only 80% of his ideal pruning target.
Interesting. So he knew he wouldn't get everything.
He understood that organizational buy-in requires compromise. By deliberately conceding 20% of the URLs to appease various department heads and legal teams, he ensured they felt their priorities were protected.
So he traded a small amount of technical perfection for absolute operational consensus.
Which is the only way a massive enterprise project actually deploys.
That is brilliant.
So we have dissected the mechanics of the crawl budget limit, the site-wide impact of the helpful content system, and the explicit Google documentation confirming that 404s are safe, expected signals.
Well, 200 OK soft 404s and mass no indexing setups actively damage crawl efficiency.
Right. And we've mapped out the data-driven execution of rewriting, redirecting, consolidating, and executing the hard delete, complete with server log analysis and internal link auditing.
This framework really transforms content pruning from a terrifying high-risk gamble into a meticulous mathematical operation. By eliminating the digital deadweight, enterprise domains can force search engines to focus entirely on their most authoritative, high-converting assets.
But, the very existence of this massive cleanup operation highlights a fundamental flaw in how we build enterprise platforms in the first place.
What do you mean?
Well, we are constantly running these reactive audits to clean up a decade of bloat. The next evolution of enterprise SEO isn't just about better pruning scripts. It's about shifting this entirely to the architectural layer.
Okay, I'm listening.
What if enterprise CMS platforms like Drupal or core WordPress builds included a mandatory expiration date field in their publishing workflows by default?
Oh, wow. Introducing a data retention lifecycle at the exact moment of publication.
Exactly that concept. Imagine if a regional marketing team spins up a programmatic landing page or a webinar registration hub. The CMS physically prevents them from publishing until they define a shelf life.
So they set the expiration for, say, 30 days after the event concludes.
Right. And on that exact date, the server automatically triggers a cron job that unpublishes the node, fires a 410 gone status code, dynamically strips the URL from the XML sitemap, and purges any internal database links pointing to it.
That architectural shift would completely eradicate the digital hoarder scenario. You are automating the entire decision matrix we just discussed, preventing the crawl budget trap from ever materializing.
The goal should really be to build digital ecosystems that self-prune, rather than requiring an agonizing cross-departmental audit every 5 years.
This is a fascinating concept.
To everyone listening, thank you for diving into the mechanics of enterprise pruning with us. Look at your server logs and Search Console data with a highly clinical, ruthless eye. The most valuable thing you can do for your search architecture this quarter might not be building something new, but finally having the technical confidence to take out the trash.